Welcome to ClickMyProject.com. Let me discuss about the project Segmentation-Based Image Copy Move Forgery Detection Scheme. Let me discuss about the abstract of the project. Detection of forgery in images has numerous applications in forensics. The copy move forensic in images changes the original pixel information from the images. The pixel information that were changed were identified. In this proposed approach, the forensic in the photography mainly copy move changes were analyzed. Initially, take the original and forgery image for input. Features will be extracted from the original and forgery images using affine transformation. Perform patch matching process between original and forgery features, which was extracted using affine transformation. Based on the patch matching process, can segment forgery portion from forgery images. Measure the performance of the precision and recall based on detection of forgery images. In this proposed system, the original and forgery image have been taken as input. For detecting forgery portion, the above mentioned task performed by the affine transformation. An affine transformation or affine map is a function between affine spaces which preserves points, straight lines, and planes. Also, sets of parallel lines remain parallel after an affine transformation. An affine transformation does not necessarily preserve angles between lines or distances between points, through it does preserve ratios of distances between points laying on a straight line. Perform patch matching process. Let me discuss about the flow diagram for our process. Initially, the original image and the forged images are taken as an input. Next, the pre-processing has been performed. The images are first resized to a particular size. The noises in the images reduces the quality of the images. In order to improve the quality of the images, we normally employ some filtering operation. Median filter is used for filtering. Median filter considers each pixel in the image in turn and looks its nearby neighbors to decide whether it is representative of its surroundings. Next, in the segmentation, where here Specialization algorithm are used for segmenting the original image and as well as the forged image. Next, in the first stage of matching, here affine transform is used. This process is the first stage of matching of images. The interested points from the images were extracted based on affine transformation. In the case of affine transformation, the scale change is in general different in each direction. The Harris Laplace detector is designed to deal with uniform scale changes, and it will therefore fail in the case of significant affine transformation. Case of an affine transformation, the scale change is not necessarily the same in every direction. Automatically selected scales do not reflect the real transformation of a point. Next, in the here the false alarm has been detected if the patch matching process has been performed for detecting the false alarm. Expected feature values from the affine transformation were then matched based on the patch matching process. Patch matching process is based on the separation of images into small patches, and the regions were then matched with define the distances between two key points. Next, in the second stage of matching, here EM based matching approaches are used. That is, expectation maximization methods were used for second stage of matching of the copy move detected region in the input images. The difference is the images were identified based on the identification of the probability of each pixel in the images, that each pixel belongs to the forgery region or normal region. The EM process is divided into E step and M step. In the expectation step, the probability of the pixels in the images were estimated, and the maximization step, the estimated probability values were compared, and from the comparison values the pixels were selected to be belonging to the forged region or not. Next, in the detection of forgery image, from the matching pixels obtained from the first stage of matching and in the second stage of matching, forged region in the images were identified. Regions identified as forged were then displayed in a different color compared to other regions. The generated map of correlation coefficient is post-processed by means of filtering and morphological operation. Finally, the CMF regions are detected, that is, copy and move forgery regions are detected. Finally, the performance has been analyzed. Performance of the process is measured based on the performance metrics like precision, recall, and F measures of the process. Let me discuss about the running procedure for our process. Select the main.template in the current folder, right-click the fill and run for executing this process. This is the main window of the segmentation-based image copy move for the detection scheme. By pressing the input image button, we can perform the read the input image from the dataset folder. Here I display the input image in the axis 1 location. Pressing the pre-processing button, we obtain the pre-processed image. Here we resize the and noise removal process will be performed in the pre-processing stage. Now by pressing the image segmentation button, perform the segmentation of images. Here SLAC algorithm is used for segmenting the images. Now by pressing the affine director button, we perform the affine transformation, and here the affine transformation points are displayed, and also the haste features are displayed in a table format. By pressing the second stage of matching, we perform the second stage of matching process using the EM based algorithm. With the help of expectation maximization algorithm, we perform the second stage of matching, and with the help of resultant of second stage of matching, we detected the region. Here I display the detected region, and also the performance of the graphs are obtained. Here this is the precision versus noise standard deviation. This graph will be performed with entire existing method, and this is the representation for noise variance versus recall graph. This is also obtained for existing and also proposed method. Here this is the for varying quality factor we obtain the precision values, and this is the by varying the quality factor we obtain the recall values, and by varying the angle location we obtain the precision value for our proposed and also existing method. By varying the angle location we perform the recall calculation for our existing and proposed method, and here we obtain the downscale rate versus precision graph, and the same downscale rate for recall also obtained, and this is the upscale rate versus precision graph, and also the upscale rate for recall graph also obtained for the existing and also proposed method. This is the bar graph representation for precision for every all for 6 images with existing system, and the recall results also obtained. Finally, the detected regions were analyzed by performing first stage and also second stage of matching. Thank you.